So we know the body needs to be in a normal range of temperature. It should be a core body temperature of around 37 degrees. When we get outside of that, bad things happen. But how does the body know? How does it know what temperature to keep us at? The hypothalamus is the thermostat for the brain. It recognizes what the core body temperature should be and then coordinates how much heat we make and lose, which is called thermogenesis and thermolysis. So like I said, the set point should be 36 to 37.5 degrees Celsius, but a bunch of things can change that. A fever, for example, is the hypothalamus cranking up the thermostat to help fight off an infection. When it's time for you to go to bed, the hypothalamus gradually decreases your core body temperature to help promote sleep. The hypothalamus gets its information from your peripheral nerves in the skin, nerves in the abdominal cavity, the spinal cord, and sometimes in the rest of the brain. It then takes this information about the current temperature, compares it to what it thinks the core body temperature should be, and then decides what to do about it. One way it can correct the temperature is called thermogenesis, which means making new heat. So there's lots of types of energy: chemical, electrical, mechanical, and thermal. And part of the body's job is to take one type of energy and turn it into another. Like when we turn glucose into ADP, and then take that ADP and turn it into mechanical energy to kick a soccer ball. But a byproduct for using any type of these energies is heat. So things like cellular metabolism generate heat as a byproduct. Things like skeletal muscle movement also generate heat, and a lot of it. There's also a lot of heat generated from just friction, moving body parts together, blood moving through vessels, that kind of thing. And lastly, digestion, turning those cheeseburgers into proteins, carbs, and fats, that generates a lot of heat. Our hypothalamus can take this idea of thermogenesis, and when it thinks we need more heat, crank it up. The basal metabolic rate is the basic amount of heat that our body produces at rest. So just sitting in a chair, a 70 kilogram man is going to make around 60 to 70 kilocalories of heat per hour. But if we get cold, the hypothalamus can release thyrotropin-releasing hormones, TRH, to the pituitary gland, which will release thyroid-stimulating hormones, TSH, to cause the thyroid to release T3 and T4, which will increase metabolism. We can also look at burning fat to make more energy. There's two types of fat in the body, white and brown. White is the insulating stuff. This is the stuff we try and lose when we go to the gym. And this is the kind of fat that's really hard to burn off. Then we have our brown fat, which is designed to be burnt and give off heat. That's its whole purpose. There's an extra protein in these tissue receptors that lets brown fat directly generate heat. Digestion is another way that we can make heat. Our small intestines absorb nutrients and proteins and fats from the food we eat, and then we use microvilli in the intestinal wall to absorb them into our blood or lymphatic tissue. But it takes a lot of energy to take things from the chyme of the small intestine and put it in the blood. And that energy also generates heat. So like I said, skeletal muscles generate tons of heat. And that's why one of the first responses of getting cold is to shiver. Even behaviorally, the body knows when it gets cold and we need to move around. Notice when you get cold and you initially want to walk around, jump on the spot or whatever, that's your body telling you to make more heat. Fun fact, the organs that make the most heat are the brain, the liver, the heart, and the skeletal muscles. Why? It's a lot of metabolism, turning one compound into another, or it's a lot of movement in those places. Stay tuned for the next one.